Hello friends, welcome back to my channel Learning Physics with Bhavya Ma'am. Today we are going to discuss about second PU or class 12 most important MCQs or CET or JEE or NEET level questions of chapter 10 Wave Optics. So here there are most important questions of chapter 10 Wave Optics. So before going to discuss these questions, if you are new to my channel, please subscribe my channel and press bell icon to get the notification of new videos. If you are already subscribed, please like, share and comment. Share these important questions to your friends who are studying in second PU or class 12. Now, let us start. The topics of wave optics is wave nature and interference of light. The first question is, by corpuscular theory of light, the phenomenon which can be explained is. So, Newton proposed this corpuscular theory of light. From this theory, we can explain refraction. So, the option is first one, A, refraction. Because interference, diffraction and polarization could not be explained by corpuscular theory. The second question is, according to corpuscular theory of light, the different colors of light are due to. So, option A, different electromagnetic waves, different force of attraction among the corpuscula, different size of the corpuscles, none of the above. So, different colors of light are because of different size of the corpusculars. So, that is option C. The third question is, which of the following is false for interference of light? So, this question was asked in J&K CET 2012. So, go through the answers properly because the question is, which of the following is false for interference of light? So, here it is mentioned false. Okay. So, we need to identify it properly. Coherence of the source is an essential condition for interference. That is correct. So, in order to have interference pattern, coherence is very important. Source must be coherent. The second option, the minima of the interference pattern need not be of zero intensity. Yes, this is also correct. Even if it is a minima, it may not be having zero intensity. The third option is interference simply redistributes light energy without destroying any of it. This is also correct because we know that interference is based on law of conservation of energy. So, interference is a modification or redistribution in the light energy. There is no destroying of it. So, that means it based on law of conservation of energy. The fourth option, the minimum of the interference pattern must always be of zero intensity. Yes, this is the correct statement. That means here this question is false. Okay, the minimum of the interference pattern must always be of zero intensity. So, this is a false statement. That means in this question, option D is correct. Okay, option D is correct. So, the question is, which of the following is false? So, fourth option is false because minima means it may not be having zero intensity. Okay. The fourth question, two coherent sources of light can be obtained by two different lamps but of the same power, two different lamps of same power and having same color, none of the above. Say, to have two coherent sources of light can be obtained by. Coherent sources cannot be obtained by lamps, different lamps, okay, or two different sources cannot be considered as coherent sources, right? So, therefore, none of the above is a correct answer. So, the fifth question is, by Huygens wave theory of light, we cannot explain the phenomenon of. Huygens wave theory, which cannot explains, which one? See, we know that Huygens wave theory explains interference, diffraction and polarization. So, therefore, photoelectric effect cannot be explained by Huygens wave theory of light. Is this clear, student? The next question, sixth one. The phenomenon of interference is shown by. See, this is one of the important question. This is asked many times. So you can see here, so many times this question has been asked, and you can expect this type of question in MCQ in board paper. So the options are longitudinal mechanical waves only, transverse mechanical waves only, electromagnetic waves only, all of the above types of waves. So the interference is a phenomenon which can be explained or which can be shown by mechanical waves as well as electromagnetic waves. Say this longitudinal and transverse are mechanical waves. Mechanical waves means it requires medium for its propagation. Longitudinal wave example is sound wave, which requires medium for its propagation. Transverse wave, water waves are transverse wave which requires a medium, or when you have a rope in your hand, and if you give up and down motion to the rope, then there is a transverse wave, so which is a mechanical wave which requires a medium. And light, or you know that X-ray, gamma rays, all these are electromagnetic waves which do not require which is not a mechanical wave. Electromagnetic waves do not require a medium for its propagation. Electromagnetic waves are transverse in nature, but it do not require any medium for its propagation. But here the question is, the phenomenon of interference is shown by all above types of waves: longitudinal, transverse and mechanical waves as well as electromagnetic waves. All these waves undergoes interference. So therefore option D is correct. Is this clear, student? The seventh question is, two coherent monochromatic light beams of intensity I and 4I are superposed. The maxima and minimum possible intensities in the resulting beam are. So here also you can say this is one of the IIT JEE level question, and this is also asked in AIMS, that means medical, AIIMS medical entrance exam, KCET 2000, okay, all medical level exams or KCET exams, this question has been asked, or this is also expected in MCQs in board paper. So how to solve this? Here there are two coherent monochromatic light beams and intensities of these two waves are given, I and 4I. When they are superimposed, that means when there is an interference of these two light waves, then maximum and minimum possible intensities in the resulting beam are. So how to calculate maximum? So let us consider I max. I max can be written as square root of I1 plus square root of I2 whole square. Okay, is it clear? So how to do square root of this? That is square root of I1 is I, square root of I1 is I plus square root of 4I. Square root of 4I is square root of 4I. 4 square root is 2. So let us write 2I whole square. So what is that? 2I plus 1I is 3I. 2I plus 1I is 3I. 3I whole square is 9I, right? So therefore C, option C, 9I. But we can't judge just by checking maximum, right? Because in option C, say here there is one small mistake, that every option's having 1, but it should be I, okay? It's 5I and I, 5I and 3I. C is for 9I and I, 9I and 3I. So first one we got it as 9I, but option C and option D both are having 9I. That's why we need to check minimum also. So how to calculate minimum? It is I minimum can be written as square root of I1 minus square root of I2 whole square. Okay, whole square. So square root of I1 is already we know it is I. Okay, 1I, because I square root is I only, right? 1 square root is 1. 4 square root is 2. So square root of 4I is 2I. So here 1 minus 2I. 1 minus 2I and square it. 2I, say 1 minus 2I is minus I. Minus I square is 1. So it is 1, right? So therefore option C. Option C. Any confusion? Go through it again. I max is square root of I1, square root of I1 plus square root of I2 whole square. I minimum is square root of I1 minus square root of I2 whole square. Okay, so it is 9I plus I. Option C. Question 8. Light appears to have straight lines since. So this is also one of the important question expected in MCQs in board paper or in KCET. So light appears to have straight lines since it is not absorbed by the atmosphere, it is reflected by the atmosphere, its wavelength is very small, its velocity is very large. So which option is correct? See, it is not absorbed by the atmosphere. Is this correct statement? Is it absorbed by the atmosphere? It is reflected by the atmosphere. See, light appears to have straight lines. It is because its wavelength is very small, right? So what is the wavelength range of light? It is wavelength range of light is 400 nanometer to 700 to 800 nanometer, which is very, very small, right? So the wavelength is very small means it appears to be almost straight line, right? So that's why its wavelength is very small is a correct answer. Next, 9th, the idea of secondary wavelets for the propagation of wave was given by Huygens. We are all familiar with this. Secondary wavelets is nothing but it is a small waves produced by the point on the primary wavefront. Okay. So this is given by Huygens. Next, 10th question. The ratio of intensities of two waves is 9:1. They are producing interference. The ratio of maximum and minimum intensity will be. So this is also very important question. So you can observe here. This is mainly asked in AIMS 2000. And so many times this question was asked in JEE and some other exams. Okay. So this is one of the important you can expect in KCET also. So the question is the ratio of intensities of two waves is 9:1. Then they are producing interference means what is the ratio of maxima and minima? So the formula is I max to I minimum is equal to, you can write in square bracket, say write like this, square of, what is that? First write square root of I1 by I2, okay, and outside the square root write plus 1 divided by, here write plus 1, and here square root of I1 plus square root of I2, okay, inside the square root, and outside the square root you write minus 1 whole square. I'll repeat, I max to I minimum is equal to square root of I1 by I2, okay, plus 1. Outside the square root you write plus 1 divided by square root of I1 by I2 minus 1 whole square. Okay, na? Is it clear? Okay. Now let us calculate. So here it is first one square root of I1 by I2, that is 9 by 1 plus 1, okay, plus 1 whole square divided by, once again, square root of 9 by 1 minus 1 whole square. That gives I max by I minimum. I max to I minimum. Okay, na? Yes. So what is the square root of 9? 3. 3 by 1 is 3. 3 plus 1 whole square. 3 plus 1 is how much? 4. 4 square is 16. Okay. Divided by, once again, 9 by 1 is 3. 9 by 1 is 9 only. Square root of 9 is 3. 3 minus 1 is 2. 2 whole square is 4. Is this clear? 16 by 4. 4 ones are 4 fours are. So therefore it is 4 by 1. Option C. Is this clear? Next, if the amplitude ratio of two sources producing interference is 3:5, the ratio of intensity is maximum and minimum. Now it is in terms of amplitude. So we know that, see, you can observe this is also very important. This is asked in KCET, right? And MCET. Okay, so now see, intensity is directly proportional to square of the amplitude, right? Or we can write square root of intensity is equal to amplitude. Amplitude can be written as square root of intensity. Okay, now. So now the ratio of intensity at maxima and minima is. So how to calculate? Once again, I max to I minimum is equal to, see, as I mentioned here, I is proportional to A square. Therefore, I max is proportional to A plus B. Let us write, there are two waves, right? So, one is A, another one is B. So, I max can be written as A plus B whole square divided by I minimum is A minus B whole square. Okay, na? So, then what is A and B? 3 and 5. Okay, A and B means A is 3, B is 5. 3 plus 5 is 8. 8 square is 64. A minus B, that is 3 minus 5 is minus 2. Minus 2 square is 4. 64 by 4, that is 4 ones are 4, 16. 16 4s are 64, right? So the answer is 16:1. Next, 12th question. For constructive interference to take place between two monochromatic light waves of wavelength lambda, the path difference should be. So, what is the condition to have path difference in case of constructive interference? So, we are all familiar with this. It is n lambda, right? Path difference delta x must be equal to n times lambda. So, n means 1, 2, 3, 4, 0, 1, 2, 3, 4. So, path difference may be 0, or it may be 1 lambda difference, or it may be 2 lambda difference. So, whenever two waves interfere, so that when crest of one wave falls on crest or trough of one wave falls on trough, then they interfere constructively and produce bright fringes. So, then the path difference must be n lambda. 13th one, two sources of waves are called coherent. So, go through here. So many times this question has been asked and it's very, very important, student. So, this is also expected in MCQ of board paper. So, two sources of waves are called coherent. So, what is a condition that two sources of waves must be coherent? Look at the option. Both have same amplitude of vibration. Both produce waves of same wavelength. Both produce waves of same wavelength having constant phase difference. Both produce waves having same velocity. So, which is correct option here? Both produce waves of same wavelength having constant phase difference. Constant phase difference is very important in case of coherent, right? Coherent means there should be either they should have same phase, or if there is a phase difference means it should be constant. Then 14th question, wavelength of light of frequency 100 Hz. So we know that speed of light c is equal to f lambda or nu lambda. Nu is frequency. Frequency is 100 Hz. Then what is a wavelength? How to calculate wavelength? Wavelength lambda is equal to c by nu. C is 3 into 10 to the power 8 divided by nu is 100, which can be written as 10 to the power 2. When this 10 to the power 2 comes to numerator, it is minus 2. So, it is 3 into 10 to the power 8 minus 2. 8 minus 2 is 6. So, 3 into 10 to the power 6, option B. Please note down this. Yes. We'll move to the next question, 15th one. In Huygens wave theory, locus of all points in the same state of vibration is called. This is a direct question. What is that called as? It's a wavefront, right? Wavefront means locus of all points vibrating in same state or same phase. Okay, the next one, wavefront means, see here, in previous question you can observe that in the question they have written the answer, right? The locus of all points in the same state of vibration is called. One word you should answer this. It's a wavefront. Now in 16th question, what is wavefront means? Wavefront means, so you just check which answer is correct. All particles in it have same phase. The first option itself is correct, right? 16th one, yay. No need of checking other options, right? Next, 17th one. For the sustained interference of light, the necessary condition is that two sources should be. This is also one of the important questions. So, interference should be sustained for long time means what should be the necessary condition? So, here they should have constant phase difference. Students, please remember, constant phase difference is very, very important in case of interference of light. Okay. Yes, so therefore the option A is correct answer. 18th one, ray diverging from point source form a wavefront. So there are three types of wavefront: spherical wavefront, cylindrical wavefront and plane wavefront, right? So if you are having one source, okay, which is point source, then what type of wavefront we are going to get? It is a spherical wavefront. If the source is line, then we are going to get cylindrical wavefront. If the source is at an infinite distance, then we are going to get plane wavefront. Okay. So here ray diverging from a point source is spherical. So if you know this concept, this is a concept based question or knowledge based question. So you can take the option B as a correct. Next one, 19th. The dual nature of light is exhibited by. So both type of nature, that is particle nature as well as wave nature, is exhibited by which phenomenon of light? So we know that photoelectric effect is a particle nature. So particle nature of light exhibits photoelectric effect. Refraction and interference is exhibited by wave nature of light. Diffraction and reflection, see here diffraction is exhibited by wave nature of light and reflection is exhibited by both, right? Both, that is wave nature as well as particle nature. But so the question is, dual nature of light is exhibited by which phenomenon? So here if you look at the option D, diffraction is exhibited by wave nature and photoelectric effect is exhibited only by particle nature, right? That's why the option D is a correct answer to this question. Next one, Huygens principle of secondary wavelets may be used to. So you can see here this question was asked in CET 2002. Huygens principle of secondary wavelets may be used to. So what is the use of secondary wavelets? If you know the principle of Huygens thoroughly, you know this answer, right? So what is the use of secondary wavelets? It finds the velocity of light in vacuum? Is it used to explain the particle behavior of light? Is it used to find the new position of the wavefront? Is it to explain the photoelectric effect? Yes. So if you know Huygens principle, then you will be knowing the answer. It is used to find the new position of wavefront. Third option, right? Okay. Next. 21. What is the path difference of destructive interference? Yes, I already mentioned the path difference of constructive interference, which is n lambda. Then what is the path difference of destructive interference? The options are n lambda, n plus 1 lambda by 2, n into lambda plus 1, 2n plus 1 lambda by 2. Okay, so there is a small correction here. 2n plus 1 means here 2 into n means you will get even number, right? So 2 into 0 is 0. So 2 into 1 is 2. 2 into 2, if n is 2 means it is 4. So 2n is even number. If you add 1, you will get odd number. Odd number into lambda by 2. Right? This is a correct option. So what is the path difference of destructive interference? 2n plus 1 lambda by 2. Next, 22. The principle of superposition is basic to the phenomenon of. Yes, student, think about it. The options are total internal reflection, interference, reflection, refraction, and polarization. So the principle of superposition is basic to which phenomenon? Think about it and comment your answer in comment section. Comment your answer in comment section. I'm waiting. Thanks for watching. I hope all these questions are helpful. Please go through it properly and note down the answers. See you in next video.